So the next topic we're going to be talking about is searching within arrays. And, well, you may imagine that already, but let me tell you that this is one of the fundamental algorithms that is just everywhere. Searching. And there's another topic that's sorting. So searching and sorting, those two tasks, they need to be performed, well, I wouldn't say in any application, but in the vast majority of applications. We're going to look at the simplest way of doing this kind of search, a way of searching that doesn't require doesn't have any prerequisites. There are some smarter ways of searching, but they would require, for example, that the data in which you're searching is already sorted. Now, the searching that we're doing here doesn't require that. The searching, searching algorithm, it's really very simple algorithm that I'm going to present. It doesn't have any prerequisites. So how are we going to search? Well, we're just going to do what's called a sequential search. We have an item of data that we're searching for, or a key that we're searching for, and we just start at the beginning, and we go through each element, and we check, is that the element that we're searching for? Is that the element that we're searching for? If not, then we go to the next one, and the next one, and the next one, and the next one, and the next one. I mean, really, really simple. The index where the value was found, if it is found, is returned by this search. And in order to signal that the search was unsuccessful, we use this sentinel value, if you want, the -1, an index position that can never be a valid index inside the array, right? A -1 is not a valid index in the array, so if we return -1, then that indicates the item that was searched for wasn't found in the array. Okay, and yeah, we're going to use a loop, of course, that goes over all the array elements. That loop, or the entire program or function, whichever way you want to look at it, sets a variable of type bool to true if the target value is found. And whenever the loop iterates and the condition is checked again, that Boolean variable found is also consulted. And then if found is true, then it returns the index where it was found. And if we reach the end of the loop, if we have gone over all the index positions, then and we didn't find it yet, then the function returns -1. Okay, so here's the main program, which isn't really of that much interest because it's pretty straightforward how to do it. Let's look at the slide that is of interest, where the search function is. Now, this search function has a const array parameter. Why? Well, because searching should not change the content of the array in which we search, right? That's pretty plausible. Then we have number used, so that's the element of which we want to check whether it is in the array. And we have, target is the element of which we want to check whether it is in the array. Number used is the number of items that we're using in the array. Okay, so here we set index 0, we set found to false, and then we have this loop that as its condition has not found and index less than number used. Yeah? So the way to read this is it is supposed to represent while we haven't found the item yet, and our index position at which we're going to check next is still less than number used, we keep doing that loop body. Remember, found is initialized to false, so when we first reach this, not found will be true. So whether we enter into this loop will depend on whether 0 is less than number used. So if number used is 0, then we won't enter the loop. If number used is anything larger than 0, yes, then we will enter the loop at least once. Now, in the loop, we check, is target equal to the array element at the current index position, at the position where our variable index tells us to look. If that is the case, then we found it, and we set found to true. And if that is not the case, then we just increment index to look at the next position, or to eventually go above or equal to number used, and thereby to terminate the loop. Then down here, before we go here, to get to this point here right after the loop, what has to have been the case? Well, either found was true, in which case not found becomes false and we get to this point, or index became greater or equal to number used, in which case we also get here. So we have two different ways, two different situations that can take us to this point here. So at this point, we're going to have to distinguish what was the case, what got us here. Did we get to this point because we found it, or did we get to this point because we exceeded the number of elements in the array, or we exhausted them? So if we found it, we return the index. If not, we return -1. So that's the logic of this search function. Are there any questions, doubts, comments?
That will only apply as long as the user puts out a number higher than 0 for it when they input it, right?
When the array has 0 elements, then index is initialized to 0, number used would be 0, and 0 is not less than 0. So we get to this point here right away, and then found is false, so we go to the else branch, so we return -1 right away. Okay, now what I want to do with you is an exercise in, I don't know, simplification. Simplify your life, right? In this case, just simplify the code. And what I hope to achieve by this, I hope to show you that even a small portion of source code like this one is worth having a second look at in order to better understand what goes on in it, and thereby to simplify the code that we're using. So first of all, down here, we're using the Boolean variable found. Can we get rid of this found down here? What is the purpose of found here? The purpose is to indicate whether we found the target value inside the array. Do we have another way of knowing that? Juan. Joan. Yes. That would be. Wait a second. Yeah. If target is equal to a of index, that's another way of doing it. Yes. I thought of a different way, but that's another way. Yes. That's a third way even. Okay. So the one I'm after is the following. If index is less than number used, at this point, you see what I'm saying? If index is less than number used at this point, then we must have gotten here because we found it.
Because it's lower than since it's lower than the index, or wait, it's lower than the number used, then it's just doing the same function as something found.
I didn't quite get that.
If I'm understanding correctly, the reason why found is put there is the same thing as finding the all number larger than index, right? It's doing the same function, it's just that. It's just shortening it out by putting found.
Yeah, but you're saying shorting it out, and what I'm after is I'm trying to get rid of some concepts that are involved here because they're making things more complicated than they need to be. So, what happens if we actually do find the target at some index position? We set found to true, and immediately afterwards we stop the loop. So index is going to be less than number used. If we never set found to true and we eventually increment index to the point where it is equal, for the sake of completeness, let's say greater or equal to number used, then obviously we didn't find it. So what we can do down here is we can replace this with an if index less than number used, and then return index and else return -1. Okay, so that part here can be changed to get rid of found. Now that we got rid of found down here, there's actually no point really in setting found to true except to ensure that we end the loop, because by saying found to true, what we achieve is that as soon as we get up to the loop condition again, we're going to stop doing the loop and we're going to go exit the loop. We're going to go after the loop. Yeah? So if you recall when we talked about the loop statements, there was the break statement that we could use to break from a loop. So instead of the found equals true, setting found equal to true, we can just use a break here. So now our loop looks like this. Break else. So that's our loop now. And as you can see, we have eliminated the use of found except for the declaration and initialization and its use here in the condition of the while loop. But it's initialized to false, and it never changes its value, and the program still runs correctly. So it's initialized to false, and here we use not found, which is always going to be true because it never changes value. So we might as well eliminate this part. So let's do that. I had forgotten the parentheses, but now it works out. Okay, so we've eliminated found, and in particular we can also eliminate the initialization. So the only initialization that we have up here is the declaration of index and initializing it to 0. So, what else can we do? There's a few other changes that we can make. There's actually two changes that we can make that we cannot combine. Right? So we need if we want to make another simplification, we need to do either the one simplification or the other. One simplification is if we do find the target value, then we break here only to be sure to return index. So what we could do instead is, instead of breaking to return index right away at this point. And then of course we never get to this point here having found target, because by the time we have found target we do return here, so there's no way we could get to this point. So the only way that we can get to this point here is by exhausting all the index positions, which means that when we get there we must return -1. Yeah? So now all this has now collapsed to this. The other way of doing it would be I revert back to having the break here and having the if index less than number used, return index, else return -1. So back to this. Now the other thing is we have a condition that tells us under what condition to actually do the loop. And inside the loop we do a test for a condition under which we want to break from the loop. So isn't it actually the opposite of this condition that we need to put up here also, that we need to join to that condition for keeping going in the loop? You see what I'm saying? Yeah? If this is the condition under which we need to break, then the opposite of that condition is the condition under which we need to keep going. And this condition, of course. So let's try to rewrite that. So the index less than number used and the target not equal to a index, that should keep us going with incrementing index. Yeah? So that becomes, if the index is less than number used and the target is not at the position index, then we increment index. And watch what I did, or observe what I did. I moved the index less than number used from the back here up to here. It would have been much less writing, well, not much less, but a little less writing if I had just put this condition to the front. But remember that we have short circuit evaluation. So we want this to be tested first. We want to first test whether index is less than number used before we use index in the indexing operation. Because if we already have an index that is greater than number used, it would be undefined to do that. So if I swap these around, it's not the same. Because I would then always use index, even if to index into the array A, even if that index is already beyond the array, the declared size of the array. So this is the better way. This is not the better, the correct way. Okay. Yeah. So that takes care of that. So those two simplifications don't combine. You have to choose one, whichever. I mean, that's a matter of taste. They're both good simplifications. It's just a matter of taste which one you prefer. Okay. Now you might say that it's not a big deal, but I think if you read this code and you think about, or the other variant that we had on the whiteboard, and you think about how the loop is going to execute, you will find it much easier to, in your mind, visualize the execution of this source code than you will find if you try to follow the execution of this code, just visualizing it. We have gotten rid of one concept out of two, one concept of variable. Previously we had the index position and we had the indication whether we found the index or not that we had to keep track of. Now we only have the index position to keep track of. And we've eliminated this notion of, yes, we did find it and that we need to keep track of that. I mean, that we need to keep track of that in a variable. Any questions or doubts? Nope. Okay, then back to this slide. I said sorting and searching and sorting are two fundamental tasks that we very often need to perform when we have a collection of data. Searching we just looked at, so let's look at sorting. When we talk about sorting, it's always sorting using some kind of comparison operation, some kind of less than or less or equal operation. That might be sorting according to the less or equal of the natural numbers, or it might be sorting lexicographically. In case you haven't heard the word before, lexicographic sorting means sorting as you would in a phone book or in a dictionary. Yeah. If two words start with the same character, well, then you take the next character in order to distinguish. It's not, I mean, some people talk about sorting their socks, right? That's just pairing them or matching them. That's not this kind of sorting that we are after here. Okay, and there are a huge number of sorting algorithms. At one point, I mean, they cleaned up the Wikipedia page, but at one point I checked the Wikipedia page and there were literally hundreds of sorting algorithms on the Wikipedia page that deals with sorting algorithms. Now they clean it up and they just highlight a few important ones, and then they have references to the outside to others. Okay, there are some that are really very efficient, and usually the ones that are very efficient are also harder to understand, at least in their entirety. So there's others that are easier to understand, but they're not as efficient, probably. So guess which ones we're going to talk about? No, we're not going to talk about the very efficient one right now. I leave that for another lecture. There's a lecture on computer algorithms that you will take, COMP3010. So towards the end of your curriculum, you will take that. Okay. So when the sort is complete, then the elements of the array are ordered such that we have this. This is not quite correct. This would only be correct if we would never ever allow any duplicate values. So in general, we only can ensure less or equal, less or equal, less or equal here as the comparison, because in general we do need to allow duplicate values. We can't just enforce that every value is distinct from all the others. Yeah, The algorithm we're talking about is called the selection sort algorithm, and it's called selection sort because it goes through a loop, and every time it goes through the loop, it selects from the remaining elements, from those elements that haven't placed into their final positions yet, it selects the next one and places it into its final position in the sorted array. So initially it starts out with the first index position with index position 0, and it selects from all the array elements the element that needs to go into position 0 in a final sorted sequence of these elements. Oh, there's another condition here that I didn't mention. Not just do we need this here to be true, we also need the final arrangement of the array to be a permutation of the initial elements of the array, right? We cannot, imagine this here with s equals. Well, if I assign 0 to every array element, I've satisfied that condition, right? If I just forcibly assign 0 to every array element. But that we can't consider that sorting, right? Because I've destroyed the original values. So one condition is that we have this chain of less or equal, and the other condition is that the final sequence of the array element is a permutation, a rearrangement of the initial elements of the array. Okay. Yeah, so this loop here does that. Place the indexed smallest element of the overall array into A of index. Clear? What's meant by that? Yeah?
Yeah, I just thinking how to use it. Like, could you see out it and then delete that and then do it again?
You would normally not do that. You would normally either have a second array, or as we will see later in a moment, actually, you can use that same array with a little thought. You can use that same array without losing any data. And then, of course, once you have sorted the elements in the array, then you can do with it whatever you like. Output it, write it to a file, sum it up, or whatever, split it in half. Who knows? Okay, that's what I'm saying. One array is sufficient to do the sorting, and the reason for that is when I want to know which element needs to go into position 0, I scan the entire array and I find an index position where the smallest element is that needs to go into position 0. And when I put it into position 0, well, then this array element from which I'm taking that value becomes unused. So the value I currently have in index position 0 of the array can be put there. So I just swap the two elements, and therefore I don't need any additional array, and I don't lose any of the values. Is that clear? Okay. And of course that can be done in every iteration of the loop. So here's an example. If these values are in our array initially, then in the first iteration of this outer loop, we need to place the smallest element into position 0. Well, we scan through the entire array. Initially 8 is smallest. Then we find a 6. Oh, now 6 is smallest. Well, 10 is larger, so that's not smaller than 6. So 6 is still our smallest we have. 2 is smaller, so that's currently our smallest. And then we see there are no smaller ones, so we scan until the end of the array, and the index position of the smallest element remains 3. And so after having scanned through them, we know that at position 3 we have the smallest element, and that's when we swap the two. And so now we have the 2 in the index position 0 and the 8 in the index position 3. And then we advance to the next index position, position 1, and we repeat the same procedure with index position 1 and all the remaining elements. Same thing, we scan over the elements. Initially 6 is the smallest, 10 is not smaller, 8 is not smaller, 16 is not smaller, 4 is smaller. So now 4 is the smallest we found so far, and we continue, and none of them are smaller. So index position 5 is the one that we're going to use to swap with index position 1. And now these two elements there are in sorted order already. Not just are they in sorted order, they're also the smallest elements, the two smallest elements of the initial array that we had. So going on like that, we end up with a sorted array eventually.
Does this have a specific name? This type of
Selection
sorting?
sort. Selection sort is the name.
Is this different from the bubble sort?
Yes. Okay, so here's a program that uses this sorting. We have our old acquaintance fill array that we use to get the values into the array. Then we have this new function sort. We have a function swap values. Obviously, we need that function to perform that swap statement, swap task. And here we have index of smallest. That is the function that performs this search in all the remaining index positions, search for the smallest element. That's what this, so that implements the loop body of this loop that we had talked about just a moment ago. So, wait a minute. Flip back. Just a second. Sort, that's where it is. So sort starts down here. Sort has an array parameter. That's not a surprise. It's not a const array parameter for obvious reasons, because it will change the array elements. And it has this number used, the number of elements we're using. We have a local variable index of next smallest. And then we have this for loop that we already talked about that we would have that goes over every index position. This outer for loop, in this outer for loop, we iterate over the next position to be finalized. Yeah, the next position that will receive the smallest remaining element of the remaining elements that we haven't put into their final positions yet. This variable, this local variable index of next smallest, is assigned the return value of calling the function index of smallest with a, that's the entire array, the current index, and number used. So from the current index up to number used, we want to search using that function index of smallest. And so after this call, we have the index of the smallest of the remaining values, and we do this swap, the swap between a of index and a of index of next smallest. Here's the implementation of index of smallest. This function does not have any business changing any of the array elements, so it receives the array parameter as a const parameter. The start index, the first index to consider, and number used, the number of array elements in the array. And the minimum, this is like, remember when we were searching for the max score, we had to do something special for the first element, because at that point we didn't have a maximum yet to compare to. So we just had to say, okay, the first element we have is the max up to now, and then we can start the loop and comparing with a max that we have. But that's the same thing here. Our min is the value that we have at the position start index, and the index of the minimum we have up to now is that start index. And then we have this loop here that starts with start index plus 1 and runs as long as index is less than number used, incrementing index every time around the loop. And if the element at that index position is less than the min that we have up to now, well, then it's our new min, and we have to record the index where we found it. And here we have this very similar invariant to the invariant that we discussed when we talked about this max score example. And the function returns the index of the min because the index is what we need up here to do the swapping. Here we have another invariant in our function sort. There's the invariant that a of 0 is less or equal to a of 1 and so on up to a of index. So they're sorted, but not only are they sorted, they are also the smallest of the original array elements. Yeah, they're the index plus 1 smallest elements of the original array. Okay, that's the invariant there. Any questions or doubts about this?
It's a function defined by IO stream. Is it a function defined by IO stream?
Well, it's not defined by IO stream. That function sort doesn't really have any business in doing anything with a stream, right? It just works on the array. Our main function that uses namespace std because it does use cout and it calls fill array, and that fill array in turn is going to deal with getting data from the input stream into the array. But once we have the data in the array, the remaining functions, I mean the sort function at least, doesn't need to be concerned with any stream at all. If we want to do anything with the sorted data afterwards, like for example output it to the user, then that's another concern, that's a different task. We don't need to do that inside the function sort. Actually, we shouldn't be doing that inside the function sort. Okay, can you write a program that will read up to 10 letters into an array and write the letters back to the screen in reverse order? Char, yes, that's where we can put the 10 letters.
Letters. Bracket 11.
Yeah, so you're suggesting to use a char array. ABCD should be outputted as DCBA. And a period should be used as a sentinel value to mark the end of the input. And of course that period is not supposed to appear in the output. So, how would you do it? How would you go about it?
First, we need an array of 10 letters.
Yeah, that's a good idea. We need a char array, let's call it letters, that has 10 elements. We don't really need the 11 elements because we're not going to use this as a string. We're just going to use this as an array of characters. So we don't need the extra position for the string terminator. Because you said 11, right?
Yeah.
We don't need that at this point.
Well, I don't get it.
Well, because we're not using it as a string. At this point, we haven't talked about strings, so we're not using it as a string. We're just using it as an array of characters, as an array of values, character values.
But doesn't that mean it'll only receive 9 in letters?
Well, come to think of it, if we want to use this more uniformly and not have an extra variable, then for intermediate variable in which we check whether the period was entered, then it might actually be a better idea to put a limit there. Okay, so what's next?
Check the array to see if it has a period. Like, check that everything is a letter.
But
until-
yes, we could do that. But can't we do that on the fly? Can't we do that on the fly in the sense that when the user enters a character, that's when we check was it a period? See what I'm saying?
Yeah, I get it.
So we definitely need a loop. That should be clear. We definitely need a loop. The question is, what is the condition for the loop? How long will this loop run?
Until not. Until
Until
not period.
Not period.
Until the character, like until the array space is
And the array space is exhausted. Yes, both are correct conditions for this. We have to consider both. Yeah. So we want that's let's use a constant size of array, whatever. Wait. No. Index starts at 0. Index is less than size of array. Index is incremented by 1. Now I haven't dealt with the period yet, but let's do that when we're inside the loop body. Now, what we want to do first inside the loop body is to do we have a character yet to check? No. So we should get one. So get a character from the user. Now, they tell us letters here. So we could assume that that excludes white space, in which case we could use the extraction operation. If we, on the other hand, interpret these letters to mean just characters in general, including white space, then we would have to we would have to use the member function get. But let's just assume it's letters. Then I can write this. Letters index. And then once I have the character, I want to check whether it's a period, right? If it's a period, then we break from the loop. And if it isn't a period, well then we increment index, we check whether the index is less than size of array, and we get the next character. So that takes care of the loop body, for reading the characters. Now what do I know at this point? At this point I know that either at position index there is a period, so my real characters that I'm interested in go up to position index -1. Index -1 in that case holds the last letter that I should output. Actually, the first one I should output. The last letter that was input by the user, but the first one I should output. If I got there, not because of the break, but because index became greater or equal to size of array, in that case also the last position. Wait a minute. It's supposed to be -1, yeah? Right, because size of array is initialized to 11, and we're supposed to allow only for 10 letters. So I have to say index less than size of array -1. Yeah. So if that here becomes false, then it becomes false after we have just incremented index. You know, we go around the loop, we increment index, we do this check, and it is false, so we get down here. So we've just incremented index. So in that case also, the last character that was entered by the user is in the position index -1. Right? So whether we leave the loop because of this, or whether we leave the loop because of this, the last character that the user entered is in position index -1. So index -1 at this point is the first character I need to output. And then the next character I need to output is index -2. And then the next character I need to output is index -3, and so on, down to index being equal to 0. So we get another loop. Course I need. Actually, I don't need the second variable at all. I can use index itself. So why does this work? This works because the decrement index right here. So we subtract 1 from the value of index with which we leave the loop. But I just explained that the first character that we need to output is at position index -1. So if I subtract 1 from index, then the first character I need to output is at position index. And then the condition here is that index is greater or equal to 0. And every time around the loop I decrement index by 1 more, and I output letter at index. So I go down, I build up the characters like this, and then there's the period, and then I make sure that index is set to this here by this operation, and then I output them going down with my index position 1 by 1, and that of course outputs them in reverse order.
So the first index minus takes the last thing that you.
It's to get back from
The last position.
the index is at this position when we leave the loop. If the user entered only 4 characters at a period, then index is the index of the period. The period we don't want to output. So the index minus is for starting with this character to output. If the user actually entered 10 characters, then index will be 11. Yeah? And then also we have to decrement 1 from that index in order to be at the position where the first character to go to the output is. Okay, that's it for today.